Good morning or good afternoon, my YouTube viewers. It is Crystal here. I'm just here this afternoon because I wanted to give you another code review. And basically, I'm not going to be able to give you the Jupyter Notebook. And the reason why is because the people who made this community competition test, they are not allowing me to make my Jupyter Notebook public. So the only thing that I can do is just go over the code with you, and then if there's something that you like in the code review, then you'll just have to stop the video and write down the code that you like. But this code is similar to lots of other code that I make, so it shouldn't be too difficult if you watch my code reviews and get my Jupyter notebooks. So I'll show you right here when we come over here to settings. It says making this notebook public will be locked until the competition ends. So it will not allow me to it won't allow me to make my code public. And in addition to that, if you look over here on output, it does not even allow me to submit my work. So I don't know how well I scored because they did not set up a mechanism where you can submit your work. So I'm just going to give you my code review. I did actually do predictions on the validation set, so you can see the validation set. But with regard to the test set, I can't tell you how well I scored on the test set because it's not even allowing me to submit work. The community competition is called Test, and it is a weather competition. So I'm not sure exactly why the people put this competition on the community competitions for Kaggle. I can understand not wanting to make the code public, okay? I can understand that, but not allowing you to submit your work. I mean, if you're not allowed to submit your work, why even put the competition up? But I had gone ahead and entered the competition, and I didn't know that I couldn't submit my work until I actually tried to submit it. So the first thing we'll do is we'll just talk about the problem statement. And before I do that, I'll say that I made this on a Jupyter Notebook in Kaggle. And as I said before, I can't leave you the link because it's not allowing me to make it public. And then we'll carry on with the problem statement. The data set we use is transformed from some real data set. Numeric features are nonlinear transformed. About 20% data become missing value. 16 numeric features, 5 nominal features, 1 label. It says our label is weather. So now that you know the label is weather and all this other information, what we'll do is we'll import the libraries. So we're going to import NumPy as NP and import. What that does is that creates your NumPy arrays, and it also does numerical computations. We're going to import pandas as PD. That creates your data frame and your series, and it carries out data processing. We're going to import OS, which is your operating system. We're going to import matplotlib.pyplot as PLT, which is your graphics visualization. And we're going to import Seaborn as SNS, which is also graphics visualization with a statistical bent to it. Then what we're going to do is we're going to use OS to actually go in and get the files. And the files are train, test, and sample submission. Then we're going to use pandas to read the files and convert them to data frames. and the files are train, test, and submission. So I made it to where you can view all of the columns of data in this data set. And then so you can see the train data frame, and you can see that, come over here to the end, and you can see weather is your label, and it's a binary classification, which means that your output is going to be either 0 or 1. We look at the info, you can see that the columns are going to be object, float, and integer. And we can see the missing values, and you can see you've got all of these missing values, and about 20% of the values are missing. So you can't really delete all of the values that are missing from the train file, because if you do that after you've deleted all of the files that are missing, you're only going to have about 300 rows of data left, and that's not enough to make an adequate prediction. And as a result of that, because you can't delete the data in the missing files, what we're going to have to do is we're going to have to impute the missing data. You got your test file. The test file is the same as the train file, except for the fact that it does not have a weather column of data, which is the label. We look at missing values in the train file, and you can see there's lots of missing values there. We look at the submission file, and this is what Kaggle would like to see if you are actually allowed to submit your work to Kaggle. Okay, so this is your label, and as you can see, we've got a class imbalance. Most of them are zeros, and a small amount of them are going to be 1. So that class imbalance is going to have to be addressed. Now what we're going to have to do is, since we're going to be normalizing the data, we're going to take the train and the test and we're going to combine them. But basically what I used to do is I used to use train.append test, and that used to be fine, but that append is now deprecated. And if you look on my blog post, you'll see that I have made a post where append is deprecated, and I say what you're supposed to use, and what basically, instead of using append, you're supposed to use pd.concat train, test. But before we do that, we're going to establish our target equals train pop weather. So we're going to take the weather out of the train and make that our target. And then we're going to create the one large data frame of comb equals pd.concat train test. And I did actually make a blog post explaining why append is now deprecated and you have to use concat now. So you always have to stay abreast of the changes in the libraries and the changes in the programming language, because Python tends to go through a lot of changes and Python's libraries tends to go through a lot of changes. And so now that we've got ChatGPT, a lot of people think that ChatGPT is going to make programmers obsolete. Well, you're going to need, as these libraries are always, and programs are always changing and they're deprecating functions and things like that, you're going to need people to go through and rewrite the code. So, I don't know. Some people think that programming is going to be dead in 5 years, or programmers aren't going to get all the money that they had previously been awarded. That might, but I still think you're always going to have a need for programmers. You know, you're always going to have a need for people to write languages, and you're always going to have a need for people to go through and recode work that's been done when code has become deprecated and the language model has changed. But I can see that maybe programmers won't be making as much money as they made in the past because this AI is going to be making programming easier. So now what I had to do was I had to timestamp the data. I wasn't sure exactly what I was going to do, so I decided to keep the date in there. So combi date equals pd dot to date time combi date, and then so you can see here that now the date column has been timestamped and it is no longer a object. So now what we have to do is we have to impute the missing values. So for call and combi, if combi.call.dtype equals date time 64ns, then what you're going to do is you're going to fill it with the most commonly used date, because I wasn't sure exactly what to do. If combi call.dtype equals object, you're going to fill it with unknown. So I wasn't sure exactly what to do, so we just said unknown. If combi call.dtype equals float, we're going to fill it with the mean. And if combi call.datetime equals int, we're going to fill it with the medium. And then so now we've got combi. And so you've got lots of unknowns and other things like that. Now what we're going to do is we're going to look at the unique values. We're going to see the number of unique values to see if there was some unique value small enough that I can make a chart out of it, like a box plot or a scatter plot or something like that. So we got all the unique values. And in the end, I decided not to make any charts, but I suppose I could have made some box plots with night cloud and day cloud. And could have made some other plots as well, but I didn't do that. Now what we're going to do is we're going to encode all of the columns that are objects. So from sklearn.preprocessing, import ordinal encoder, enc equals ordinal encoder for calling combi. If combi call.dtype equals object, you're going to transform it and reshape it. If combi.call datetime equals datetime 64, you're going to reshape it and transform it as well. So that's what we do there. And you notice that if you look on sklearn doesn't tell you that you have to reshape it. But I can't get it to work unless it's reshaped. So I might do a blog post to say that ordinal encoder doesn't work unless you reshape it. And this is the code that you have to use. Now I might do that because it won't work. If you don't reshape the values, it won't work. Now we're going to do a heat map. Core equals combi.core, SNS heat map core. So you can see we've got a heat map. You can see some of the columns of data are highly correlated, but not too highly correlated. And so for that reason, I decided not to remove any columns of data. And now what we're going to do is we're going to normalize the data. Combi equals combi minus combi.min over combi.max minus combi.min combi. So what we've done is we've converted all of the data to a value between 0 and 1. And the reason why is because it's going to be easier for the model to make a prediction if it's a value between 0 and 1. Now we define our x and our y variables. Your x are your independent variables and your y is your dependent variable. So y is your target, which we previously created in this program. X equals combi 0 to the length of train rows, and X test equals column B, the length of train rows to the end. And then we print it, so you can see we've got 21 columns of data for X and X test. Now what we're going to do is we're going to use sklearn's train test split to split the data into training and validation sets, and the test size is going to be 0.1, and you can see that we printed the size as well. Now we're going to define our model, and I decided in this instance to define a perceptron, and the reason why I decided to use this perceptron is because the perceptron is a binary classification model, and it's been around since the 1950s. That's how old neural networks are, and so I decided to go ahead and do that. So model equals perceptron, random state equals 42, class weight equals balanced, dot fit X train, Y train, and then you print the score, which is 70%. And then if I hadn't normalized the data, my score would be higher, but it wouldn't do as good a job as picking out the ones. And I'd also like to say that I tried to use extra trees, which is similar to random forest, and although my accuracy was higher, it didn't pick up the ones. So I decided to go with the lower accuracy because more ones would be picked out. I printed off the model coefficient and the model intercept because these are important things when you're dealing with logistic regression, and the perceptron isn't logistic regression, it's a linear model, but it does have a step in it where it'll only be 0 or 1, but logistic regression tends to work better than step from what I've been studying. Now we predict on our validation set, and you can see we've got 70% on our validation set. We put it on a confusion matrix, and you can see that it picked out more ones. It picked out 288 ones, and 85 were zeros that they should have been 1. And that's the best score that I was able to get whenever I normalized the data. And so now what I did was I created a data frame where it had the actual values against the predicted values. So you can see that. And then now what we're going to do is we're going to predict on the test set. Predictions equals model.predict X test, and you can see the predictions. You can see a value count on it. We had 22,820 zeros and 12024 ones. We prepare our submission. Submission weather equals predictions. Submission.toCSV is submission.csv. Index equals false. Submission equals pd.readCSV submission, and then you've got submission. And this is what I would have submitted to Kaggle if they had allowed me to submit it, but they didn't allow me to submit it. You can see here on output, there's no submit button. And when I tried to submit, because you can come over here, there's a submit to Kaggle, and it didn't work either. But what I'm going to do, I'm going to come over here to test. That's the competition. I'm going to come over here to discussion. There's no discussions found. So we're going to say a new topic. Okay. And you can say, okay. So there what we do. Then we publish the topic. So now we've got, now it just says unable to submit. So there you go. And then we've got the leaderboard. There's nobody on the leaderboard because nobody's allowed to submit it. Check the code. There's not any code because nobody's allowed to make their code public. So that's it. That's it for this code review. I hope you like it. I hope you got some information from it. Since I can't give you the Jupyter Notebook for it, if you find a piece of code you like, I would suggest that you just stop the tape and write the code down there. So thank you very much for watching this video. I look forward to making more code reviews for you in the future. If you like my video, please like, subscribe, and share. And if you want to be notified whenever I make a new video, please tap onto the bell button. And what I want to do is I want to dedicate this video to my cousin Paul Holt. He was murdered over the weekend in a carjacking, and he died. He was shot in the chest. And I haven't seen my family in a really long time because I'm living in the UK and I don't have any money to get back to the US. But I did hear about it, so I want to dedicate this video to him, and I hope he's in a better place. So thank you again for watching my video. See you next time.